Good day, everyone. I am Anne Clarence M. Galora, and today we will be learning about frequency distribution table. So, what is frequency distribution table? Frequency distribution is one way to organize data in more convenient form. It is a table that displays frequencies for different categories, values of a counting variable, or class intervals. Consider the example. The following are the third quarter grades of 30 students in math. Using this set of data, how can we make a frequency distribution table? So, there are steps in constructing a frequency distribution table. Step 1. Determine the range. The range is the difference between the highest and the lowest value. So based on the example, 98 is our highest value and 71 is our lowest value. So the difference between 98 and 97 is 27. Therefore, the range is 27. So take note of that. Step 2. Decide the number of classes or class intervals into which the data are to group. The number of class intervals is arbitrarily chosen depending on the size and range of the data. As a general guideline, the recommended number of class intervals is between 5 to 20. So, for this example, we choose 6 as our class intervals. So, the first column of our table is class interval having a 6 row below, wherein the first class interval is on the bottom. Step 3. Determine the class width or the I. So in determining or obtaining the class width, we divide the range by the number of the class intervals. We know that the range is equal to 27 and the number of the class interval is equal to 6. So I is equal to 4.5. The class width must have the same number of the significant figures as the data values. Therefore, we round up to 4.5, so we can take the I is equal to 5. So take note that our class width is equal to 5. Step 4. List the lower and upper class limits of the first class interval. So in listing the lower class limit, it should be divisible by the class width. We know that the lowest value is equal to 71, which is not divisible by our class width 5. So we get the newest number less than 71 that is divisible by 5, which is 70. Therefore, the lower class limit is 70 and the upper class limit is 74. We notice that the 70 to 74 have a width of 5. So, our first class interval is 70 to 74. Step 5. List all the succeeding class intervals. Obtaining the lower and upper class limit of the next class interval is by adding the class width to the lowest and upper class limit of the preceding interval until the highest value, 98, is obtained. So in our table, we already have the first class interval, which is 70 to 74. If we add 5 to the lower and upper class limit, we have 75 to 79. And so on until we get 95 to 99, wherein the highest value, 98, is between or located on the last class interval, 95. The next step is to tally the data value in each class interval. So we already completed the first column, which is the class interval. The next is the tally. So to tally, we must see for the example. So to tally the data value in our first class interval 70 to 74, there are three. It is the 71, 72, and 73. And then we continue to tally the other number or the grades of the student. The next is to find the frequency. Frequency is referred to the number of data value that is given in the class. So in our first class interval, it has 3. The next is 5 and so on until the last have the 2. In checking, we must check if the sum of the frequency is just equal to the total number of values in the data set. So the total frequency is 30 and the total number value in the data set is 30, which we have 30 students. The next is to make an additional column for the other information needed. The other information needed is the class boundaries. Class boundaries are obtained by subtracting the upper limit of the first class interval, which is 74, from the lower limit of the second class interval, which is 75. Then divide the result by 5, so we have 0.5. To obtain the lower class boundaries, subtract 0.5 from the lower limits of the class intervals. The lower limits of the class intervals are the 70, 75, 80, 85, 90, and 95. Thus, the lower boundaries are 69.5, 74.5, 79.5, 84.5, 89.5, and 94.5. The next is to obtain the upper class boundaries. To obtain the upper class boundaries, add 0.5 to the upper limits of the class intervals. The upper limits of the class intervals are the 74, 79, 84, 89, 94, and 99. Thus, the upper boundaries are 74.5, 79.5, 84.5, 89.5, 94.5, and 99.5. So, we have our class boundaries. The purpose of our class boundaries is to avoid the gaps in the continuous number of scale. The other additional column is the class marks. Class mark or class midpoint of the class interval is obtained by finding the average of the upper class limit and lower class limit. So based on our constructed table, the upper class limit and the lower class limit of our first class interval is 70 and 74. To find the average, we must add the upper class limit and lower class limit divided by 2. So, the class mark of our first class interval is 72, and then we can get the 77 for the second class interval, and so on until our sixth class interval or the last class interval is 97. So, this is the frequency distribution of third quarter grades in mathematics. Hope you understand something in this video. Thank you for watching my video.